Hello everyone. Today we will discuss about the suppression of carrier and sidebands. In this lecture we are going to study the concept of the suppression of carrier, single sidebands, and the advantages of suppression of carrier and sidebands, and the vestigial sideband transmission and its advantages and disadvantages of this VSB. In previous lecture we have discussed the concept of sidebands and power distribution in the carrier and sidebands. And we found that the carrier carries 2/3 of the total power, and lower sideband and upper sideband carries the equal power, that is 1/6 of total power. As you know, the sideband frequencies contain all the information of the modulating signal. The carrier itself conveys no information. The carrier can be transmitted and received, but unless modulation occurs, no information will be transmitted. And when modulation occurs, sidebands are produced, and that all the transmitted information is contained within the sidebands. Only 1/3 of the total power transmission is allotted to the sidebands, while remaining 2/3 power is wasted in transmitting the carrier. So, in today's lecture, we will discuss about the necessity of the suppression of the carrier and a single sideband. Now let us start with the discussion with DSB-SC. So what is this DSB-SC? It is nothing but the Double Sideband Suppressed Carrier system. In the process of amplitude modulation, the modulated wave consists of the carrier wave and two sidebands. The modulated wave has the information only in the sidebands, as already discussed. Sideband is nothing but a band of frequencies containing power, which are lower and higher frequencies of the carrier frequency. The transmission of signal which contains a carrier along with two sidebands can be termed as double sideband full carrier. So here in this diagram, if you say the centered position of the carrier, if you take the dark line, so it will be the system of double sideband full carrier. Such a transmission is inefficient because 2/3 of the power is being wasted in the carrier, which carries no information, as we have discussed in previous lecture. If this carrier is suppressed and the saved power is distributed to the two sidebands, then such a process is called Double Sideband Suppressed Carrier, or simply DSB-SC. It is shown in the following figure. The carrier is suppressed, which is shown by dotted line, and the sidebands are allowed for transmission. Now let us discuss the generation of DSB-SC signals. Here we need a modulating signal and the carrier signal. So this signal is obtained by multiplication of baseband signal, that is denoted by xt, with carrier signal cos of omega ct. And the resultant signal of this product modulator will produce the DSB-SC signal. Now we shall discuss about the mathematical expression for DSB-SC signal. Let us consider the same mathematical expressions for modulating and carrier signals as we have considered in the earlier lectures. That is, modulating signal is given by x of t is equal to ax cos of in bracket angle 2 pi fx t, and the carrier signal c of t is equal to sc cos of 2 pi fct. Mathematically, we can represent this equation of DSB-SC wave as the product of modulating and carrier signal. So here S of t equal to x of t and into the c of t. Substituting the above equations in this, we will get the last equation, that is s of t is equal to ac cos of 2 pi fxt and into the cos of 2 pi fct. So using the trigonometry, cos of a into cos of b, that is equal to 1/2 cos of a plus b plus cos of a minus b. So we will obtain the last equation. The last equation is given here. So the maximum frequency is fc plus fx and the minimum frequency is fc minus fx. So the bandwidth can be calculated fx minus f minimum. If we substitute these values, we will get bandwidth is equal to 2 times fx. The bandwidth of DSB-SC wave is same as that of amplitude modulated wave. It is equal to twice the frequency of the modulating signal. Now we shall discuss about what is SSB-SC. Now before discussing the SSB-SC, that is Single Sideband Suppressed Carrier system, let us discuss what is the need of this SSB-SC. First of all, we can discuss about its advantages of single sideband transmission. We have derived the expression that the carrier contains 2/3 of the total power, contains no information. So we can say that amplitude modulation is insufficient efficient method of communication since 2/3 of the transmitted power is wasted. The actual information is within the sidebands. And the efficiency of amplitude modulation can be increased by removing or suppressing the carrier before it is coupled to the antenna for the transmission. So in the last slide, we have discussed about the suppression of the carrier. Now, what is the need of suppression of the single sideband? As you know, both sidebands carry the equal information. So why should waste again the power in sending the information with the two sidebands? So the concept of single sideband suppressed carrier system comes out. So this process of suppressing one of the sidebands along with the carrier and transmitting a single sideband. What are the advantages of single sideband system? At 100% modulation, carrier in a amplitude modulated signal requires 2/3 of power, but it does not contain any information. To transmit single sideband, only 1/6 of the total power is required. So the power required to transmit carrier other wideband is saved in SSB transmission. The power devoted to transmit carrier and other sideband can be utilized to transmit single sideband and thereby producing a stronger signal. And as you know, the stronger signal propagates over a longer distance and more reliable received at greater distance. If amplitude modulation signal is transmitted, interference may occur between several carrier frequencies, resulting in steady audio whistles or beats. Noise also gets added to all signals in the communication medium or in the receiver itself. If the signal bandwidth is restricted, the receiver circuit are made with a narrower bandwidth. Automatically, noise gets filtered. Since SSB signal requires less bandwidth than amplitude modulated signals or DSB signal. Naturally, there will be less noise associated with it. So, the single sideband has high power, and as the power allotted for both the carrier and other sidebands is utilized in transmitting the single sideband. Now, what is vestigial sideband technique? Vestigial sideband technique is a compromise between DSB and SSB techniques. The word vestige means a part. If a part of lower sideband is also transmitted along with whole of the upper sideband, the method is known as vestigial sideband transmission. The most important advantage of VSB system is the bandwidth reduction. By transmitting only the part of lower sideband, more number of TV channels can be accommodated in a frequency spectrum. So in figure, it is shown that the VSB modulation part of lower sideband and the upper sideband. So this information is with the part of the LSB and USB. In SSB modulation, when sidebands is passed through the filters, the band pass filter may not work perfectly in practice. So some of the information may get lost. To avoid this loss, this VSB technique is used. Along with the upper sideband, a part of the lower sideband is also being transmitted in this technique. A guard band of very small width is laid on either side of VSB in order to avoid the interferences. And this technique is mostly used in television transmission. What are the advantages and disadvantages of VSB technique? As we have discussed, advantages of VSB are highly efficient method, reduction in bandwidth, and designing of the filter is highly accurate. It is easy. The transmission of low frequency components is possible without difficulty and possesses good phase characteristics. What are the disadvantages of VSB? Bandwidth when compared to SSB is required more, and the method of demodulation is a complex method. So let us summarize the today's lecture. Only 1/3 of total transmission power is allotted to the sidebands, while remaining 2/3 is vested in transmitting carrier. If carrier is not transmitted in amplitude modulation, there is considerable saving in power. To save power and bandwidth, DSB-SC modulation technique is adopted. And the Vestigial Sideband Modulation is mostly used in television transmission. This is all for today's lecture.